Topic of this presentation is phase control converter. Let us start with main contents of it, which are: Introduction to phase control converters, types of phase control converters, working principle of phase control converters, advantages and disadvantages of phase control converters, applications of phase control converters. Phase control converters are a type of power electronic converter. They can provide controllable output DC voltage in a single unit instead of a three-phase autotransformer and a diode bridge rectifier. The controlled rectifier is obtained by replacing the diodes of the uncontrolled rectifier with thyristors. Control over the output DC voltage is obtained by controlling the conduction interval of each thyristor. This method is known as phase control, and converters are also called phase-controlled converters. There are different types of phase control converters. Here are some of them: rotary phase converters, static phase converters, sine wave inverters. Rotary phase converters are electrical machines that convert single-phase power into three-phase power. They use an induction generator motor and a control panel with capacitance and a start circuit. They are used to run three-phase loads where utility three-phase power is not available or too expensive. Here is how a rotary phase converter works. A rotary phase converter is an electrical machine that converts power from one polyphase system to another, converting through rotary motion. Typically, single-phase electric power is used to produce three-phase electric power locally to run three-phase loads in premises where only single-phase is available. The main function of this phase converter is to convert a single-phase source of power into three-phase source of power. A basic three-phase induction motor will have three windings, each end connected to terminals typically numbered, arbitrarily, as L1, L2, and L3, and sometimes T1, T2, T3. A three-phase induction motor can be run at 2/3 of its rated horsepower on single-phase power applied to a single winding, once spun up by some means. A three-phase motor running on a single phase cannot start itself because it lacks the other phases to create a rotation on its own. A three-phase induction motor that is spinning under single-phase power applied to terminals L1 and L2 will generate an electric potential, voltage, across terminal L3 in respect with L1 and L2. However, L1 to L3 and L2 to L3 will be 120 degrees out of phase with the input voltage, thus creating three-phase power. However, without current injection, special idler windings, or other means of regulation, the voltage will sag when a load is applied. Static phase converters are devices similar to rotary phase converters, only without an idler motor generator. A typical three-phase induction motor has three windings, and if you are trying to start it on a single-phase power current, it will lack the needed third phase to start itself. A static phase converter is used to generate three-phase power during the starting of a motor. Once the motor starts, the static converter drops out and the motor runs on single-phase power. There is about a 1/3 power reduction in the motor's horsepower. A static phase converter uses motor start capacitors to start a three-phase motor on single-phase power. These capacitors are disconnected once the motor reaches full RPM and the motor continues to run on the two single-phase lines of power. 2/3 of the motor windings are being energized, producing approximately 2/3 of the motor's power. Sine wave inverters are more expensive than modified sine wave inverters. Sine wave inverters are more efficient than modified sine wave inverters. Sine wave inverters are better for sensitive electronics like laptops and TVs. Sine wave inverters are quieter than modified sine wave inverters. Sine wave inverters are more reliable than modified sine wave inverters. Here are some points that explain how a sine wave inverter works. The DC voltage is converted into AC voltage by using an oscillator circuit. The oscillator circuit generates a square wave. The square wave is then passed through a filter circuit. The filter circuit removes the high-frequency components from the square wave. The output of the filter circuit is a pure sine wave. Phase-controlled converters are used to convert fixed-frequency and fixed-voltage AC power into variable DC voltage output. The output DC voltage is controlled by controlling the conduction interval of each thyristor, a method known as phase control. These converters are also called phase-controlled converters. The phase control of the converters is modulated by a sine or trapezoidal wave. The uncontrolled diodes in uncontrolled rectifiers are replaced by controlled thyristor family of devices such as SCRs in phase-controlled rectifiers. Phase-controlled converters are used to convert fixed-frequency and fixed-voltage AC power into variable DC voltage output. The output DC voltage is controlled by controlling the conduction interval of each thyristor, a method known as phase control. The phase control of the converters is modulated by a sine or trapezoidal wave. In phase-controlled rectifier circuits, diodes are replaced by SCRs to allow control of the conduction period or the phase of the conducting waveform. Since the voltage or current at the output is controlled by varying or delaying the phase of the conducting waveforms, such circuits are also known as phase-controlled converters. The advantages of phase control converters include regulating the output voltage, achieving high efficiency at high operating frequencies, reduced switching losses, low EMI and stress. Phase control has two major disadvantages. The chopped waveform produces harmonics, multiples of the supply frequency, that reflect back into the supply system. These harmonics may in extreme cases interfere with other equipment. The rapid switching of the thyristors causes the load current to rise very quickly, producing high-frequency oscillations. Phase-controlled AC to DC converter circuits are used in traction systems, electrochemical processes, magnet power supplies, high-voltage DC transmission, DC motor drives. Thanks for watching. That is all for today's video on phase control converter. I hope you found it useful and interesting. I welcome your suggestions in comment box on what topic you want me to cover. If you want to see more videos like this, please subscribe my channel and click the bell icon to get notified whenever I upload a new video. Never forget to like and share.